Am I banned from drinks now? Yeah. Did you know that's what I was going to say? Did you know that's what I was going to say?
Probably.
Let's not open that up anymore today, okay?
Right. Shake it up first.
Shh. Hey. Yeah, okay, good. All right, people. So before you do that little karyotype thing, we've got to figure out what these abnormalities are. There's a couple karyotypes that I'll show you in there. There's one that I put in there and I never did fix it, I guess. All right, now. All right, here we go. So the first thing is simply chromosome abnormalities. And the first type of chromosome abnormality deals with the number abnormality. Like you're going to have a trisomy or you're going to have a monosomy. And why is that? That's caused by what we call non-disjunction. That simply means that they have failed to separate during meiosis. So either the chromatids or the homologous chromosomes have failed to separate. And so you're going to end up with a number abnormality.
I see. That makes sense.
So if we look here, these are your gametes. This represents egg, and then these would be the sperm, excuse me, with the chromosomes. Okay, so remember, homologous chromosome, you're getting one. It's a pair, have the same genes, okay, in the same location. You are getting one from mom, one from dad. So here's the first step of meiosis right here. Everything's going along good. Okay, these have separated. They're into two separate cells, two egg cells. But at the second step of meiosis, things aren't going as well. These still separate into the two cells. However, these two, this failed to do any separation. Just went right into this third egg cell. Therefore, this one has nothing. So, if any of these get fertilized, these two are fine. This is homologous chromosomes. These two zygotes now are fine. These are not. This one would be a trisomy. It has an extra chromosome. This one is a monosomy. It just has one chromosome from the dad, nothing from the mom. So we would consider this a monosomy. This has three. Two from mom, one from dad. That's a trisomy. So in this instance, the 4 cells here you'd have a 50% probability of having normal, 50% of having a trisomy or a monosomy. That happens. And that is usually as you get older that can take place. So like my friend, when she had her children, I think she's 47. So she had one child at about 45. So they would have done genetic testing to make sure that this was not happening, a trisomy or a monosomy, among other things. This one, there's no cells that are going to have a normal number of chromosomes. Why? Because the non-disjunction happens at the beginning of meiosis 1. So right here, no chromosomes have gone into this egg or into this gamete. They've all gone here. So now you're going to have 2 cells, trisomy. Has 3 of them. 2 cells with a monosomy. So none of this, on this instance, none of them would be normal numbered. So you've got 2 that non-disjunction will cause. They'll cause a trisomy, tri meaning 3. So on your quiz, you're going to have to let me know if you're looking at a trisomy or not. So why would this be harmful? Why is having an extra chromosome harmful? It doesn't seem like it should be.
You get an excess dose of genes.
Mm-hmm. The big thing is you get more genes. Genes code for protein. And because you've got all of these proteins being made, they become non-functional. It's not going to work. Depending on where the trisomy is, depends on how harmful it is. And you can have 1 trisomy on a karyotype, you can have a lot of trisomies on a karyotype. It just depends. So like if you look here, here's a karyotype. This is the 23rd pair. As usual, that's your sex chromosomes. Is this male or female? Brendan, is this male or female? Male, that's right. You've got an X and a Y, very small. Now, on the karyotype that I'm going to show you, and on some of them that I'm going to ask you to look at for your quiz, they put the Y ahead of the X. I don't see that very often. It's usually XY, but every once in a while you might see that. So karyotypers would make the karyotype and then look to see where the problem is. This one isn't very difficult to see. It's a 21 here. So you've got a trisomy 21. Trisomy 21 doesn't involve as many genes. It's a smaller chromosome. It's the smallest chromosome out of the 22 pair. Remember we talked about that, where this one's actually bigger than this 21 here. They didn't realize that when they named it. When they found out about trisomy 21 and Down syndrome, they'd already named it, so they decided to keep it rather than switch it. Non-disjunction can also cause what I talked about earlier, which is a monosomy. Mono meaning 1. So you delete an entire chromosome.
What do you think is worse?
Depends on where it's at. So remember, a homologous pair, you're getting 1 chromosome from mom, 1 chromosome from dad. They're a matched set, and you need that match. Because a genotype, how many alleles or genes do you have in a genotype? Just usual. How many? Is it 2 or 3 or 4? 2. You only have 2 in a genotype. You're going to get 1 from mom, 1 from dad. If you don't have that, guess what? Your proteins aren't going to get made. They're not going to know what to code for. So that's a problem when you're lacking genes. That one, I don't know why. That's a monosomy. I think I made a mistake. That should be a trisomy. That's
Which one?
Klinefelter's.
Well, no, on the sex chromosome.
No, you've got XXY. That's Klinefelter's. That's a trisomy.
Oh, then I see that now.
23. So I don't know
thought it
why.
was
I'll have to
separate.
change that.
They're together.
All right. The next part is polyploidy. This is very we don't have this. In animals, humans, we cannot survive. Plants can.
just like be bigger?
We'll talk about that. So polyploidy, non-disjunction of all chromosomes. In other words, it's a duplication of your full set of chromosomes. So if we have 46 chromosomes and if we were polyploids, how many would we have now? 90 what? 46 plus 46 people.
92.
92. We'd have 92 chromosomes. We can't survive. Polyploids in plants are quite common. And Brian said, are they large? Yes, they are. They're larger. And so you will see them a lot in, well, in the grocery store. You ever seen strawberries and they're large, right? You ever see those? Yeah, I mean, that's what you buy. They're usually octoploids. They have 8 chromosomes. That's what makes them larger. Blueberries. Did you ever get blueberries and they're a pretty good size? Those are
Grapes?
probably a polyploid. Yep, some grapes would be polyploids. Have you ever gotten wild blueberries? Or you've gone and you're going to make a blueberry muffin and it's a blueberry muffin mix and you've gotten, and they'll say wild blueberries in there. You look at the wild blueberry as opposed to the blueberries that you would get from the store. Wild blueberries are quite small, like maybe this size, where a blueberry cultivated is a lot larger. So what happens is polyploids on plants, they're mutations, but they stick around and they get cultivated because they give you a better yield, is what happens. Apples, a lot of them are polyploids. Like you get Honeycrisp, I'll guarantee you the large Honeycrisp are polyploids. Where if you get organic, they're going to be a lot smaller. So the last part, you can also have segment mutations. The first one is duplication, where one part of the chromosome gets duplicated. So like a section gets duplicated. Sometimes that happens, just no rhyme nor reason. Sometimes it can happen during crossing over. Is this for me? Okay. I collected these guys. So in duplication, you've got one section of DNA. That's the problem because it's not going to match up with the other homologous chromosome. It's not matching, so it doesn't know what to do. It depends on where it's at, depends on how severe it is. But when you see some of these karyotypes, you'll see that some of these chromosome mutations can cause things that you wouldn't be expecting them to cause, like a leukemia or something of that nature. The next one is a deletion. Just part of the chromosome is deleted. A section of it gets deleted. So now, it'll be fine. This right before that centromere, it's fine. But now, this section is deleted. It's not going to match up very well at all. That's going to be an issue. Deletion, inversion, all of that can happen during like crossing over. There's a lot of problems that can take place crossing over because you've got one arm of the chromosome unattaching itself and crossing over with the second arm that's detached. So if they're detached, you can have issues. And so that's where sometimes they get lost. That would be a deletion, maybe a translocation, an inversion, something like that. The next one is just what I got done saying. That's an inversion. So that's where a segment of chromosomes would be doing crossing over, unattaches itself, reattaches, but attaches upside down. That's an issue. So if you look here, this one is hard to see. On 16, inverted, so it's upside down. So like if you've got the word cat, does it mean the same thing as tack? No, you'd have issues. These two would probably line up, you know, that would probably line up because these would be in the same gene location, but these would not line up, would not be good, not in the same gene location, doesn't know what to do. So it's not going to make any proteins, or if it does, they're going to be pretty much non-functional. And then the very last one is translocation. In translocation, you get a segment that breaks. Trans means across, location means place. You get a segment that breaks off and goes to a different spot. So it either attaches itself to a different chromosome, non-homologous pair. So maybe on 3 that detaches itself and goes to 7. Well, what do you think happens?
Probably some.
That's not coding for the same what? Genes,
Protein,
right? Yeah. So if it's not coding for the same genes, it's going to be able to make protein. No.
Well.
Not very well.
Don't skip
So
it.
all of this deals with not making functional proteins, basically. Because the genes are not where they need to be. They're not where they should be.
Is that it for the notes?
Yeah.
Do we have a test soon?
You're going to have a quiz. And in this little unit, we spent quite a bit of time on karyotypes. So I've got quite a few karyotypes that I'll have you I'll ask you and have you tell me what they are, like what the abnormality is.
What are we doing on Tuesday?
Why?
I was just wondering.
You can look it up. It's online.